Hello, people. So I, follow one of these X accounts and load calculation for staircases. I looked at the formula. It's overthought. Staircases are a lot more simple, a lot more simple than you think. All right, a lot more simple than you think. Let's just dissect the stairs, starting at the wall, for example. This section here is a cantilevered floor. That's all it is. It's cantilever. That's all it is. It should be designed as a cantilever, but now it's got a load, the staircase hanging off of it. Okay, it's supporting on there. Now it has a rotation like this, so it puts a moment inside on the cantilever. Sorry, wrong color. A cantilever in here. Right here is where it puts it in tension. So somewhere about here will put it in tension. Your fracture, too high. Correction, too low. So somewhere about there, you'd see a crack start developing where you'd want to break. It can be compressive or tension crack, depending on how the reinforcement is inside here, how it separates. At the bottom of the step, all right, the rotation, in this case we have the two staircases. Let's clean this up. The two staircases, this is a gusset plate, if you will, where they're interlocked with reinforcement, but with a cantilever coming off it. Here's your cantilever. All right, so here's your cantilever here. We'll change that color one more time. And again, that's Great Cat. That's Great Cat trying to get part of the program. Let's go like this. So here's your cantilever. Okay, and you can bring your depending on how they poured it, and the reinforcement going over. And the reinforcement does go over into the staircase, into the upper stairs, as we can see indicated there. So we can count that going over. This becomes a gusset, and let's do the gusset in this format. Let's include wherever the steel engulfs the section. So yeah, the gusset looks something like that because of the reinforcement, the way it goes in the concrete. So there's your gusset plate. So you still have this without. So what I want you to think of is, what if you remove this? What would be holding those stairs in place? Well, it would be the steel down here, and the stairs would want to rotate there, separate at the top here, and create a buckle, a bursting, a spalling of concrete there, just without the top landing or cantilever, without this top landing or cantilever there. It would want to rotate down and collapse onto these steps here. All right, it would also create such a load that somewhere about here on this on the pad on this cantilever section, without this in place, would want to fracture that, break and all the load of it would want to fracture it here. All right, so that you need the gusset idea, but you need the gusset system to work, but you also need the cantilever to be strong enough. This top section is critical in maintaining stability. The bottom section of the first landing here, I'm not counting this as the first landing, I'm counting this as grade. So your first landing, it goes up and or down, both directions. And the considering it's two-way stairs, that is critical along with the one up here. All right, you need these to interlock, lock in with no deflection, and behave as such. As such. Now the steel up here is lacking because remember it wants to rotate, and there's no steel going across there, going out to here to help with the cantilever. Recall your cantilever is going to be mostly top steel to hold it up all the way out to the end, and you can hook it. There's some bottom steel there too. And you can even hook these together to help integrate the top steel and bottom steel together to help you with shear forces. And that's just a very rigid cantilever. With that said, you then can now integrate your steel into this system. And don't be stingy. Go ahead and do top steel and bottom steel for that. Oops. All right, so now you're helping. You're taking on part of this load here. They do transition the bottom steel, as you can see here, into top steel of the steps. But it should be this bottom steel, this top steel should be the top steel up here. That's what you come across and then down. Now that's going to help integrate it. But they use it on the bottom steel, which is just going to make it, all it's going to have is you're just going to have a rigid step when it breaks free. This is going to be rigid. You'll have a fracture here, and nothing new of it. As you can see, the limited steel of all that steel, remember, think of it like a gusset, it's just one cross steel right there where they cross each other. That's it. You get a nice flexural moment there. To get that flexural moment, this rotation down, you will need some spalling here. So it would have to have some stresses there to create the spalling of the concrete there. That will not happen until you get some rotation down here. That this whole staircase, the upper staircase there, the rotation down, vibration, etc., it will happen and you'll get that fracture. I can go into more steel details on these steps, and it's not, I'm just giving you a glean of it, but I want you to think of how the steel becomes gusset plated with the interaction. Like this steel here, this top steel, it's nice, so it's going to help with the cantilever, but so the rotation of this cantilever to help rotating it down is that top steel. And the load that wants to help do it, to rotate it down, is this whole staircase. And as you can see, they brought this steel here, right up to the bottom steel there, and that's it. That's the underside of the cantilever. That's the underside. It is useless. It just made the step strong. It's useless. It just came up to it and stopped. All right, it didn't turn and develop more. If anything, this steel right here, should have gone up and developed across the top to help support it in the cantilever mode. Trying to come down, they can't do that because the top of the stairs would protect it. Would help it in that cantilever mode. So this one is just making the steps rigid, but it's not engulfing into that gusset idea as I told you. Now, the only one that bottom stairs coming up, we only have one piece of steel right there that actually comes into it. There it is there. I'm sorry, let me back that out a bit. It only comes into it near the midsection of here to here. It's right there. Right about the middle third, or closer to the middle of it. It's the only section that comes in there. There's no integration with steel. It's concrete coming in contact, but then that's just, a concrete paste just trying to hold it together. Now, do I count this little bit here? Well, it's not much cover. Right there. There's not much cover on that for it to count much. It would be the bottom steel anyway. And I don't have that as giving much love. So once again, the steel should have come up here, captured here. This steel should have come up here and captured here into the cantilever. All right. Those are just the 2 points I want to bring out to bring your attention. Down here we've got in essence a pin location. Yeah, someone's stuck. Just wanted to catch a lock. Open the door. Probably the office door. All right, take care, guys. I gotta go. I gotta go find a loose cat. Take care. Hope you enjoy this much of the video. Love you. Bye.